Hi, this is Dr. T, and welcome to my desktop. So this is a continuation on the video from Intro to Metabolism, and in this case, I'm going to be jumping into glycolysis, fermentation, and the Cori cycle. So without further ado, glycolysis. So we've got ourselves glycolysis, and on this one, once we've got a couple of steps, not my favorite image. Here's probably a better series of images. So what we're going to be doing is we're going to start out with glucose, and we're going to actually use ATP. Remember, that's our energy currency for the cell. That's where kind of our immediate use energy is. So we're going to use ATP, turn to ADP. We're going to add a phosphate. We're actually going to do this twice. This, let's see if I can talk, serves two core functions. The first function is that by doing this, this glucose 6-phosphate is not glucose. The glucose transporters in the cell membrane transport glucose. They do not transfer glucose 6-phosphate. This allows you to bring it in and lock it in the cell. So it brings it in, and then you shut the door behind it, metaphorically speaking, because you have to change it. That way you can keep pulling glucose in, and it doesn't try and get out. Second, by adding ATP twice, we're going to get the energy going to get enough energy to proceed with this particular reaction. And that's going to give us enough energy to coast down through the rest of the pathway so that this thing will go. You need enough energy, even if you remember activation energy. So if you've got your reaction, it's going to give you energy. You still have to get a nice kickstart. And this is giving us that kickstart. This is giving us enough high energy that we can start breaking apart and then making some energy out. Couple other quick points. Notice how we have NAD plus to NADH. This is going to come back in two areas. One, this is what we call coenzymes. So coenzymes are cofactors that come and go, but they're recycled. So this is normally recycled by electron transport chain, and that gives you a ton of ATP when it does that. Absolutely a ton of sweet energy, but that requires oxygen. Absolutely requires oxygen to do it because you got those electrons you just added on there. They got to go somewhere, and that somewhere is oxygen. If you are running without oxygen, though, in an anaerobic system, you still have to recycle this. Otherwise, the whole thing stops. So what you're going to do is jump into fermentation. And when we do fermentation, we're basically wasting the energy, but just trying to recycle this. Typically, we will break this at about this part or so, kind of right in this area. And before this, we have the preparatory phase or the energy input phase. And then after this part, which is, right in this area, you have the payoff phase where you get your energy back. And so you get more energy back than you put in, which is good. It's kind of like making money. You want to get more money out than you put in. But you actually don't get a lot. So the glycolysis gives you only a tiny, tiny amount of energy. That NADH is really where the sweet energy is. And it's going to end in pyruvate. And that pyruvate can go further. But I'm going to leave that pyruvate going further for a different video into the energy production, but I do want to talk about fermentation. Okay, so I've got some fermentation, and so let's take a quick look at this guy. Okay, so here's our cell. In here is the mitochondria. Outside of this is the cytoplasm. Glycolysis takes place in the cytoplasm. Now, if it is anaerobic, the next part, everything that's taking place in the mitochondria won't work. So everything else shuts down. You can do glycolysis, but you can't go any further. So what you need to do is recycle that NADH. It has got to be recycled, otherwise you're done completely. Now, as humans, this will not give us enough energy. It will give us a little bit more energy than we have. So in situations where we're running anaerobic, like we're working out really hard, in those situations, we will do this, and I'll get more into the Cori cycle here in a second. But in order to, do more of that, we're going to have to, we have to recycle this, but this won't cut it for us. For yeast, for bacteria, many of them, this is good enough. They live simple lives, low need. So you're going to take the glycolysis, and you've got two choices. As humans, we turn it into lactic acid. And by doing this, you'll notice how glycolysis goes NAD to NADH, lactic acid goes NADH to NAD. That's recycling it. So now you get that lactic acid. And that, of course, is what builds up in your muscles if you're working out really hard. Also, some bacteria do this. They're going to be kind of the ones used to make pickles and that kind of stuff. Alternatively, you can go and you can make ethanol instead of lactic acid. Now, the downside of ethanol is that once you've made it, in order to process it, you're going to have some oxygen, and you typically lose a little bit more energy. You can't do gluconeogenesis with ethanol. You can process it straight for energy, but you can't go back and do gluconeogenesis. That said, ethanol is a bit less toxic, so you're going to just be making an insane amount of this and dumping it outside, and you're going to be floating around in your own metabolic waste, which sounds disgusting, partially because it is. Then ethanol is a much better choice. That's what yeast do. Yeast, when they're in an anaerobic situation, they make ethanol. Ethanol, they just float around in the ethanol, and that's why we have alcoholic things. Now, in humans, we're going to do one step further because we cannot run anaerobic for any length of time. We can do so for a brief period of time. So in our muscles, we might be working out really hard. We're going to build up lactate, and that's one of the reasons your muscles get sore. Not the only one, but one of the reasons they get sore when you're really working out. You're doing glucose to pyruvate, you're making lactate, you're running anaerobic because you're using way too much energy at that moment. Your bloodstream just cannot get enough oxygen to those muscles because you are really working it. Okay, so it's going to take glucose to come with lactate. Lactate is going to get shipped to the liver, and then the liver is going to use the lactate. With lactate, you can do gluconeogenesis, reform the glucose, ship that back to the muscle. Now, this isn't really going to be a particularly great real-time thing. It's going to be trying. This is, you're making a bunch of lactic acid, you're processing it as fast as possible. But essentially what's going to happen is that eventually you're going to slow down, you're going to get more oxygen, and that's going to allow the liver to catch up. It's going to be trying to do this process while you're working out really hard, but it's, once again, during this situation, you are running above your kind of sustain level. So, anaerobic working out, you cannot sustain that for long periods of time. Aerobic, you can, because you can run through the full metabolism pathway. Okay, so yeah, there is Cori cycle. We talked about fermentation, which was this one. And we talked about glycolysis as well as an overview of metabolism. So next time, I'm going to jump into citric acid cycle and maybe electron transport. So have a nice day and see you in the next video.